guys, Dan Edelman, PowerWool Insulation. So I'm here at the Atlanta Craftsman project with Chris Lammer-Giddens of LG Squared. We're here and we're basically going to be doing Rigiboard exterior continuous insulation, and what we're going to be talking about is a lot about the continuity of all the different control layers. So you obviously have water, you have air, you have vapor, and you have thermal. So we're going to dive deep into all four of those layers, but mostly the thermal control layer, which is what PowerWool really is. So we're going to go down to the house where Chris is working, and we're going to go check it out. Hey, what's going on, Chris?
What's up, Dan?
How are you?
Good
to see you as always.
Always,
Yeah, great project that you got here, the Atlanta Craftsman.
Yeah.
Very looking forward to learning more about all the application details.
Cool.
So tell me, what am I even standing on right now to start kind of at the bottom up?
You are standing on a thermally isolated slab.
Whoa.
This is the front porch, and a lot of times you see the slab for the house just kind of continues on through, and you build, or you might do a step down and then build your wall there.
Right.
But we're intentionally separating this from the house slab so we don't have a lot of heat loss and gain. That's a superhighway concrete.
So this is not even connected to the house at all. No rebar or anything.
Nothing. We have a 4-inch separation, and that 4 inches is filled with stone wool insulation, and that's
Awesome.
that goes around the entire perimeter of the house.
Awesome.
It's on the edge of the slab. So this you see is 2 inches.
Yeah.
The 4 inches is at the edge of the slab, so we can control that, is because concrete and steel are the most thermally conductive materials that we build with in houses. So we want to control that heat loss, and so we beef up the 4 inches there, and then we go back to 2 inches up here, and it's a cost savings thing. It's also just feasibility. It's easier to work with 2 inches than it is 4 sometimes.
Right.
So this was, thoughtful. Like, we intentionally went from 4 to 2 for that reason.
Okay.
Yeah.
All right.
Yeah.
And then tell me a little bit about this detail,
Sure.
what we're seeing here, because that, to me, I'm from the Northeast.
Yeah.
We don't do a lot of this.
Okay.
So what is that for?
Yeah. Well, we have a brick water table. It's coming up to about 3 feet.
Okay.
And this is a cavity drainage system. So any water that may get behind the brick will have a way out. So this is a mesh that's going to go in between one of the two courses of brick. So instead of weep holes, this is a continuous weep mesh product.
Okay.
So like every 3 or 4 inches there, you've got a little width of the mesh.
Just like a little bit of this weepingness
That's
right here.
Yes.
That basically.
Yeah, so water comes down the cavity here if it gets in.
Yep.
And it slopes out this way, and the mortar just right on top of this, and then you have a drip here, a little drip edge,
Yeah.
to allow that moisture to shed away from the building.
So from the outside in, you're basically talking brick, airspace.
Airspace, yep. We've got
Then
about a 2-inch airspace here.
2-inch airspace, which is always good because mortar will get shoved back there. So
Well, this
that too.
this part of the drainage system here holds holds that mortar up off of this
off the
flash
ground, so if it gets behind,
so that it can get behind it and go around it, and then it's
drain.
Yeah. So it's a really slick system. The slab that I mentioned, right? So it's actually only, well, right now we've got this footer here is actually for that brick water table, and that's it. This goes around the entire house, and within that, it's 8 inches thick, 12 inches wide, and within that, we call it a containment footing. We have 8 inches of gravel. So we have, what it was good for the contractor to be able to, when he brought in his gravel, he had a screed, so he knew where to fill up the rock to and pack it to, but also just it contains it from spilling out, because you can imagine now if there was gravel down there, it'd just be a mess at this location, right? But this slab sits on top of that 8 inches of gravel, and it's just an 8-inch slab. Nothing, no turn downs, nothing.
Wow.
And so we by doing that, we're able to have a 2-inch separation between this footer and the slab, because the entire slab is sitting on 2 inches of stone wool. And so we've another thermal separation here. So we're not losing heat through this footer, into the ground.
Yep.
And the slab edge is covered with 4 inches of insulation, so it's completely thermally isolated.
So this same detail, do you think you could, we're in climate zone 3.
Yeah.
Can we do this in climate zone 5 or 6?
This works where you have a frost depth of about 12 inches.
Okay, so no.
12 to 18 maybe.
Okay.
So a variation of this, yes. All
Yeah.
you need to do is get that insulation deeper,
Yep.
but when you get further north and you have 36-inch frost depth,
Yeah.
then you have to develop a different foundation.
Right.
There are ways to do that. We don't need to talk about them here.
Right,
Yes,
yeah.
This can work, but it's one that you have to run. You have to talk to
Still need your
structural
footers further down.
up north. Yes,
Yeah.
most likely. Or I mean, they up there they'll do big floating slabs,
Yeah.
but it's on a much thicker layer of insulation, and it's usually like EPS or something.
Right. Okay.
And because that has more structural capacity, but this can work still, and this just needs to be engineered.
Right.
Yeah.
Cool.
Yeah.
Awesome.
Cool.
Well, let's go check out the other side of the house, and we'll actually start talking about above grade and what we're doing there.
Yeah, that's good.
So this is really cool, Chris,
Yeah,
what you got here. So we're above grade now.
Yeah.
You know, tell me what is the wall assembly? Let's start from the outside because that's where we are to the inside.
Sure. So we have the brick water table, and above that we go to a lap siding, and then we
Okay.
go to a cedar shake on this upper floor.
Okay.
And that's going to attach to a 1x4 furring strip that's aligned with the studs. They're all vertical, so we'll have that vertical drainage. And then this is 2 inches of stone wool insulation. It's the most rigid stone wool insulation that we've found to use on the exterior, and we're using this for its rigidity because we want to try to keep that lap siding super straight.
Yep.
And we've used other products. Some of them, they get really squashy, and it makes it difficult to keep things aligned. They can do it, but it takes more work, a lot of laser shooting and things. And so this gives us a little more forgiveness in that. So it's 2 inches of stone wool. It's sitting on a fluid applied membrane. It's a fluid applied water resistive barrier.
Okay, and that's the blue.
It's the blue stuff.
Yep,
Yeah.
yep.
This makes it a Smurf house, right?
Yep.
But it's STPE based, and that there is an actual chemical term for that, but
Okay.
I call it sticks to practically everything
Okay.
because it does. It's brick, masonry, concrete, steel, all of it, and wood.
Yep.
And it'll just stick to it, and if things move, it goes with it. So this and it's vapor open,
Yeah.
and so it's a 2-coat system. And
Okay.
that's over the plywood, and then we do
On plywood, so
on-
CDX.
Yeah, so it's a half-inch CDX plywood over 2x6s at 24 inches on center, and that's going to be filled with a dense pack, like a stone wool, a dense pack, or maybe not dense pack, but a loose fill
Yep.
type product.
Yeah. Yeah. Loose fill stone wool.
Yep. That's
Yeah.
right. Yeah,
And then
so-
just drywall.
and then drywall. Yes.
Okay, so no interior smart vapor retarders.
No, we don't
or-
need it because
you don't
we're
need it.
controlling everything on the outside. This,
Yeah.
as you know, you remember, we did a blower door test of this with the sheathing over all the windows. So we were testing our water resistant barrier, our air barrier,
Yeah.
for that test, and we got down to a 0.018.
Wow.
And most of the leakage was happening around the
Around
blower
the
door
blower
frame,
door.
right? So
Yeah.
essentially, we're zero leakage.
Yeah.
So, and we used a painter to put this stuff on, the
Yeah.
blue barrier. So but yes, we're controlling everything to the outside because that is where that way we have all of our control layers. This is 2 inches of insulation. This is keeping our sheathing warm. So now that means everything's good to the outside. The insulation in the inside is adding thermal resistance and comfort to the home, but we're not necessarily needing it to keep the sheathing warm because we've done it right here. Yeah.
Awesome.
Yeah.
Well, thank you.
Yeah, sure.
And then we're gonna go move up to the roof.
Let's
we
go.
might not actually stand on the roof, but we'll see.
Let's look.
All right.
All right.
All right, Chris. Oh, way to put me to work. All right.
Absolutely. Let's get this done,
Let's get this done. So tell me, what are we doing up here? So it looks quite interesting. I noticed that this is actually a vapor permeable self-adhered roof underlayment.
It is, yes. Yeah, so we're doing 4 inches of stone wool on the roof here, and we're putting it over this. This is the roof underlayment. It is vapor open. We do have more CDX. It's 5/8 inch
Okay.
CDX for the roof, And then we're doing 2x12s at 24 inches on center, and we're filling the cavities with more blown in stone wool. This 4 inches on the roof is going to be the same depth of our heavy timber rafters. So we're going to take a 4x8 and notch the back 2 feet of it, or 4 feet of it. It's only going to be 6 feet long. 2 feet is going to overhang, and then 4 feet up the rake. And we're going to have the insulation is going to be flush with that. So then when we put our plywood, or more plywood on top of that, the sheathing layer, then everything's flush.
Okay.
So and so that's where we get this Monopoly or Catan framing detail with the overhangs. Yeah.
Awesome. Well, let's put it down just to kind of mock up what it's going to look like at the end.
Yeah. So this is actually the 2-inch product that we use the 2-inch sometimes to get 2 layers. We intentionally do 2 layers sometimes so we can stagger seams.
Okay.
Because there's some, for water, if there is an issue with water on a roof, which you build it right, it won't, right? But if something does happen, let the water just shed on down. If it gets through one of the seams, it has another layer to shed. So, but on this project, we're using a full 4-inch depth.
Yep.
This is the wall product right here.
And so this is an R16.8 on top of the roof, but it's continuous.
100%.
So talk to me a little bit about, like, now a lot of the building codes are actually talking about U factor. So if you could talk a little bit about U factor versus R value, because like where I am, it's R60 is the code.
Yeah.
But when you start putting it continuously, you really don't need that much.
Yeah, so if you look at the total through wall R, or the total R value of the assembly, right? So if you put R38, which we're gonna do in this assembly, inside we've got 2x12s, 24 inches on center. R38 goes into the cavity, but when you take out the 25%, 20 to 25% of framing out of that layer, your R value decreases, because it's a total when you take all of the U values of each one. And then with continuous, there's no interruption. You get 16.8 all the way. You get what you pay for, basically.
Wear your flannel.
Yeah, that's right. Everything on the outside, right? And it has to be head to toe, because you wear a jacket, it's got an opening at the bottom. That jacket has to go around your head, around your feet, if you're really going to do it right. And that's what we're doing here.
Not just zipping up the front like your kids are doing. Yeah.
So doing it over your head and under your feet, super important, to get, and continuity. So this, just like we see here, we're running the roof into the wall insulation here where it goes up to the next roof, and the same at the edge of this roof here, going down the wall.
So your flashing is all behind the Ridgy board.
Yes, it's behind. So the blue barrier runs down to this underlayment here. The underlayment laps over that, and it's sealed to the blue barrier. So our WRB behind the underlayment, that's our flashing detail, and that flashes down into this. We have a secondary drainage here. This is up higher. The crew felt like they wanted to get a little extra, get it out before it gets to this point. So we don't have, it's just kind of redundancy.
Good belt and suspenders approach, though.
And there's no thermal bridging here because it's just tape. So it works well. It actually holds to the insulation. It doesn't have to seal to it. It's just there to shed the water.
And again, going back to your intro to all of this, it's not the products, it's the process.
It's the process of putting all of your control layers and all of your systems together, because each one of these layers is a system. Water control system, air control system, vapor control system, thermal control system, and the system of putting them all together, they create this one continuous system around the house to protect it, to make this house last a really long time, to keep it comfortable, healthy, and durable.
And from beginning of time, one of the biggest reasons why people were building shelter was to control their environment.
That's right.
And I'm sweating crazy up here. I'm in Atlanta, Georgia, and I'm wearing what Joe Stiebrick says, you don't put black shingles on your roof. Well, I'm wearing a black shirt on the roof. You're at night, nice in the shade.
I'm in the shade, that's right.
But yeah, so let's continue on.
Absolutely. So
all right.
Let's go find a shady spot.
Yeah, sounds good.
Okay.
All right, so Chris, tell me a little bit about these corner details. So I see that the pieces are actually every other one like brick pattern.
Sure.
And then what are you going to address, because you have lap siding on here, so you're going to have this horizontal siding, and then what are you going to do vertical here, because your studs really fall about 3 inches in.
They do, yeah. So we got because of the 1/2-inch plywood, we got 2.5 inches basically before we can hit a stud, and you don't really want to hit the edge of a stud.
Right.
So we're going to span this and sort of cantilever our furring strip. Instead of a 1x4, we'll use a 1x6. So we'll get plenty of attachment with and embedment back in the stud with our 1x6, and that cantilevers out, and we'll do that on both sides, so we get a really nice solid backing for our siding, because our siding is actually, it's beveled. We're not doing trim.
Oh, you're not.
So we're going to have a beveled siding, so we really need a solid substrate.
Right, especially here where it's more of a walking way.
Yeah.
And you could clip this or hit it, so now it's a solid corner, so you're not going to have that issue with breaking.
That's right.
But if you did have like a corner piece, it's also nice to have that nailing strip further out, and you could go with a much nicer, tight, piece of trim.
Yeah, because if you had a 1x6, say a 1x4 or 1x6 corner trim, and you're attaching it to a 1x4 that's back here, you still have that cantilever, and those two can separate. And you really want that solid, connection backing for that.
Definitely.
Yeah.
Cool.
Yeah.
Let's go check out some other details.
Let's do it.
So, all right, so we're at a window detail. So this is pretty interesting how it looks like you cut back a little bit. So what's going on here? And again, this is going to be a window here. Yeah.
This is not the final design. No, we want to have good, solid attachment of our trim to the exterior and, of course, the inside trim. And when you're dealing with some insulation, whatever kind of continuous insulation you have, when you reach this corner, it becomes a little tricky on where do you attach the trim.
And just before we get to that point, you are using clipped windows instead of a flanged window. So this is mostly just going to be for a clip window, not a flanged window.
That's right. These are from Europe. They do have the clips attached to the inside, so we don't have, the flange would normally go here, but our window is going to set in here, and we're going to have a 2x4 here, so that we have then it's flush with the 1x4s, so that all of our siding and trim can't come flush to this corner, and then we have our return trim going in.
Right.
Yeah.
Perfect. Yeah. Awesome. Let's go inside and actually see the other side of here, because you did a really cool thermally broken window detail too.
Yeah.
So,
all right, let's
go. Ah, this is awesome. Yeah. So this is a thermally broken window. So you are using European tilt turns, so it is a clip system. So I see the blocks and then PowerWool in here. So how's that all working together? Yeah,
so whatever type of window you use, we're using European windows. They've got the clip system, or you use a flanged window. One of the things we can't do, that's difficult to do, is to continue continuous insulation into the window without some sort of a buck system like we've done here. And they do make there's some foam products, foam plastic products. We use all stone wool on everything, and so we had to develop this. This is not out there yet, so we came up with this idea where we take and give our windows a place for attachment, which is on the inside. It's where the clips attach, and we have more blocking on the outside, and the insulation goes in between this staggered blocking, so we have fully continuous thermal control. Right?
Yeah.
And so these are where we're attaching the windows, and then on the outside we attach the trim. At the sill, we have a little bit of a slope here, because that's where we have a lot of the failure, is down in the sill part. Sometimes you'll see flashing only go up to here, but we're doing it fully around the window, because in case anywhere in the window we get some moisture, we don't want any of that to get in, especially with an insulation like this.
Right.
If it's enough, it'll move through the insulation.
Exactly.
So we want to really protect that. This stuff, the way this attaches to it, this fluid applied, is this sort of serves as a backer rod. This right here is just like one continuous membrane.
Right.
But then at the sill, when the water gets down to the bottom, it needs a way out. So we give it a slope so it can drain out past the bottom of the window.
Yeah, and because the stone wool or the power wool has a little grips on it, you know, with all the different fibers, it's able to really grab into that. And then once it cures, it's really embedded into probably the top like 1/16 of an inch or, you know, 32nd of an inch. But that's all you need to really get this real tenacious bond that you're getting.
Yeah.
The other thing that I noticed is, you know, your window manufacturer is very happy because they're still hitting solid blocking. They're not going through a foam or a mineral wool product to get to that flange. So you get a really solid connection.
We do. And this is their recommended spacing right here.
Yeah.
You know, so we stuck to the recommendations. We could go tighter. Some cases we did go tighter because we just wanted everything to be equal.
Yeah.
And we also had to maintain a certain spacing from the corners. You have to go at least 8 inches from the corner. We don't we don't want blocking right in the corner because you can then see where there might be a thermal bridge.
Yeah.
Because you don't have the continuity.
Well, and I thought I saw Matt, the builder here, doing a window detail, but before the liquid flashing. Let's go check it out and talk to him as well.
Okay, cool.
All right.
Let's do it.
Oh, hey, what's going on, Matt?
It's good.
That is a good detail. So here we actually have the stone wool exposed, the power wool exposed. So how was kind of building these? I know obviously they took more time, but you know, overall, what did you think as a contractor? By the way, this is Matt with Sawhorse.
All right. So, well, the first one, we had no idea like what this detail or how long it was going to take. So we had 2 laborers out here. We had the architect who came up with this detail and myself. I brought all the tools. The first theory was like, you know, how does this cut? Is this something when we have to use a little saw, cut it by hand?
Yeah.
No, we're not going to do that. We tried that with a couple of these blocks. Like, let's try a table saw next. I also brought a wet saw. So, because I heard you can cut it with a wet saw. The table saw ended up doing the best. And the reason is we had the guide on there. It was a new blade. So we're fine with that. We ripped it on there. But also what I liked about the table saw, unlike the wet saw, we're able to create a little bit of a curve right here and a slope. So we did the calculations. It's 4.7, let's just call it 5 degrees.
Yeah.
Where all the water here is able to hit this and drain out.
And then you still have a back dam here because of the difference in
exactly. And we're able to use the limitations of the blade, because it was like a small, like this is as high as the blade would go.
Right.
So it kind of worked out for us. And then we edged it a little bit, created this little bit of a back dam. Well, the window's going to sit here. We're going to seal all the way around all 4 sides. So any moisture that gets in there is going to drain out. We also did another experiment. We were able to see if the PolyGuard was able to stick to this.
Right.
Sticks to it really well.
Yep.
And that worked out really well. So we're able to use products that we loved and used in the past in a different way, and then try a different way of cutting it. But the real fun part of this is like we had to do lots of these windows. So the first window that we did probably took us about 32 man hours. Maybe some discussion and stuff. There might have been a lunch break in there. But still, it was a lot of man hours just doing the calculations with our little abacus and whatnot. The next one we did is Chris came up with the formula and said, this is how often you're supposed to have these blocks. Plugged it to a spreadsheet, printed it out, named all the windows, handed it to the guys, like, don't think about it. Mark on center for each of these blocks. So we have a block on the inside and a block on the outside.
Right.
And then come back, we used one of those multi-tools with a square hole saw. It's actually for electricians.
Okay.
And we just cut all these in
once
it's set in place. Because my worry was we're going to do this, try to put it up there, it cracks or something like that, or the math is a little bit off. It's like, don't worry about the math. So we ripped all these down first, ripped the base down, put that slope in it with the curve, put all these around in one phase. The next phase, and then by marking these, we knew exactly where to put the fasteners.
Right.
So we were able to miss the blocks. And then we came back, cut the blocks in, put them in, it all worked out. So
awesome.
I really like the detail or continuous insulation within the thermal buck, but also the way Chris with LG Squared designed these in such a way where we're meeting the manufacturer's specifications. We're able to screw all these in, and everything's fastened on the inside, not the outside. So the European windows, the fasteners on the inside, where the American windows, you're kind of nailing to that nail fin on the outside, which is also your drainage plane, which is not necessarily the best way of holding it. Or you've got to put a bunch of shims in there, and then we can't create that good air seal on the inside. So this is a very good detail for creating that air seal and maintaining that building envelope tightness.
Awesome. Well, thank you very much, Matt. It's been a
thanks.
pleasure. Well, guys, it's been quite a day at the Atlanta Craftsman with both Chris Lammer-Giddens and Matt Hoots of Sawhorse. So, and basically, if you guys ever have any technical questions, feel free to reach out. SalesUSA@PowerWoolInsulation.com or technical@PowerWoolInsulation.com. Definitely subscribe to our channel, YouTube, Instagram, and any other ones that we have going on. So, till next time, guys.